In this video, we're going to go over on concavity and inflection point. Now, inflection point occurs at a point whereby the second derivative is equal to 0. If second derivative is equal to 0, then we're going to get the inflection point. If second derivative is greater than 0, then the shape of the graph will be concave up. So if second derivative is smaller than 0, then the graph will be concave down. This are called a second derivative test. Now let us put this information of second derivative test on practice. Let us try to work on some practice problems based on second derivative. Let us go ahead and begin. Okay, let us try this one. F of x is equal to x cubed minus 12x squared plus 36x. Then determine the inflection point. So on part A, we need to set up the second derivative to be equal to 0. So it's going to be f prime of x is equal to 3 times 1, it's going to be 3x squared, and 2 times negative 12, it's going to be negative 24x plus 36. Then if we get the second derivative, it's gonna be f prime of x is equal to 2 times 3. 2 times 3 is 6 x squared, x to the power of 1, then minus 24. Then inflection point occurs at a point whereby the second derivative is equal to 0. Now let us solve for x. So it's gonna be 6x is equal to, if you transpose negative 24 to the other side of the equation, you're gonna get positive 24. And if you divide both sides by 6, you're gonna get x is equal to 4. 24 divided by 6 is simply 4. Now to get the y coordinates that's gonna pair with this x, we're gonna substitute x is equal to 4 into the original equation f. Let me erase some stuffs here. And our second derivative, I'm not gonna erase our second derivative because let me just write our second derivative here, because we're gonna use our second derivative for our second problem. So our second derivative is 6x minus 24. This is a second derivative. So let me just erase here. Let me just erase here, and x is equal to 4. So okay, so we need to substitute x is equal to 4 to f of x. So we're gonna get f of 4 is equal to 4 into 3 minus 12 into 4 squared plus 36 into 4. Let me fetch my calculator. Just give me 30 seconds to fetch my calculator. Okay, I'm back. Let me punch this on my calculator. So it's gonna be 4 cubed minus 12 into 4 squared. Okay, it's 4 cubed minus 12 into 4 squared plus 36 into 4, then you're gonna get 16. So you're gonna get 16. So therefore the inflection point is going to be 4 paired with 16. That's how you get the inflection point. Now let us try part B. Part B, we need to find where the graph is concave up and at which point will be the graph concave down. So this is how you can do this. So earlier I've said that the graph will be concave up. The graph will be concave up at f prime w at f double prime of x must be greater than 0. Then the graph will be concave up. So our second derivative, it's simply 6x minus 24, and it should be greater than 0. And if we solve for x, f of x will be concave up for all values of x that are going to be greater than 4, and f of x will be concave down, for all values of x that are going to be smaller than 4. Let me erase here. That are smaller than 4. So let us try another one. The best way to learn maths is to put everything on practice. Let us try another one. Let us try this one. F of x is equal to 2x cubed minus 6x squared plus 6x minus 3. Then determine the inflection point. So we need to differentiate all the way up to second derivative. So we're going to get f prime of x is equal to 3 times 2, you're going to get 6x squared minus 12x plus 6. And if we determine the second derivative, it's going to be equal to 2 times 6. 2 times 6 is 12. X minus 12. And we need to set up our second derivative to be equal to 0 and solve for x. So here you're going to be left with 12x is equal to 12. If you divide both sides by 12, 12 and 12, they will cancel out, and you'll be left with x is equal to 1. This is our x coordinates of the stationary of the inflection point, and substitutes x is equal to 1 into f. Let me erase here, and remember our second derivative is 12x minus 12. So let me just erase here. We need to substitute x is equal to 1 into f of x. So it's going to be f of 1 is equal to 2 into 1 cube minus 6 into 1 squared plus 6 into 1 minus 3. Then it's going to be equal to 2 into 1 cube minus 6 into 1 squared plus 6 into 1 minus 3. So we're going to get negative 1. Therefore, our coordinates of inflection point, it's going to be 1 paired with negative 1. Okay, so we need to determine at which point will be the graph be concave up and also concave down. So for concave up, so second derivative, we need to set up the second derivative to be greater than 0, and our second derivative is simply 12x minus 12 must be greater than 0. So x should be greater than 1. Let me erase here. And for concave down, so x must be smaller than 1. By the way, feel free to pause the video and try this one for yourself. This is our last example for today's video. So by the way, feel free to pause the video and try this one for yourself. So we need to first determine the first derivative, and it's gonna be 3x squared minus 18x. Then if you determine second derivative, it's gonna be equals to 2 times 3. We're gonna get 6x minus 18, and we need to set up our second derivative to be equals to 0. So it's gonna be, and we need to solve for x. So if you solve for x, we need to transpose negative 18 to the other side of the equation, and we're gonna get positive 18. We need to divide both sides by 6. 6 and 6, they will cancel out, and we're gonna be left with 18 divided by 6. We're gonna get 3. So x value for the inflection point is simply 3. Let me write my second derivative here. It's 6x minus 18. Now let me erase everything here. Okay, we need to substitute 3 on the original function. So it's gonna be f of 3 is equals to 3 cubed minus 9 into 3 squared minus 27, and you're gonna get 3 cubed minus 9 into 3 squared minus 27, and we're gonna get negative 81. Yeah, we're gonna get negative 81. So the coordinates of the inflection point, it's gonna be 3 paired with negative 81. So to determine where the graph is concave up, you need to set up the second derivative to be greater than 0. So it's gonna be 6x minus 18 must be greater than 0. And x must be greater than 3. So for the part whereby the graph will be concave down, x will be smaller than 3. For all values of x that are going to be smaller than 3, the graph will be concave down. And that's it for today's video, and thanks for watching this video. Have a nice day.